For the final step in this example, let's go ahead and compute the radius of the circles based on the distance from the attractor point. That way, when we move the attractor point around, the circles will respond to it. And as the attractor point gets closer, they'll rescale. So we're going to use a neat function called geometry. It's kind of a general purpose function available. It's called geometry distance 2. That'll figure out the distance between any 2 points in dynamo geometry. We're going to go ahead and though add a little bit of a scaling factor. I just have a little number slider, or I can use a number as a scaling factor just to kind of make the impact of the scaling or the attraction a little bit stronger or lesser. And what I'm going to do is basically use a little bit of a code block to go through and kind of figure out what the radius wants to be. I'm going to take the scaling factor and divide it by the distance to the attractor. And I'm going to add a little bit to that. The reason I'm going to do that is if I just happen to have my point landing right on one of the radius or circle radii center points, what will happen is I'll be dividing by 0, and I want to avoid that. So you have to kind of come up with some little scheme to help you avoid dividing by 0 so you don't get infinity. Okay, so we're going to compute that circle radius, and then based on that, finally, we'll do is we'll just use the circle by center point radius. We'll just change the radius from our fixed value to the value that we're computing. So let's take a look at what that looks like. So here we are, we have our graph. I've downloaded kind of the latest starting point file for step 3. And what we're going to do is basically look at some geometry. What I'm going to do is take the list of all these different center points and feed that in as one of the things that we're going to compare to. Then I'm also going to go through and take wherever the attractor point is right now and feed that in there. Okay, so what this is going to do is give me a big list of all the different distances between wherever the attractor point is and where we are right now, or the center point of the circle. From that, we're going to basically compute some sort of a scaling factor. And again, you can do this as a couple of different nodes. I'm going to do this just by kind of doing a little code block that just says scaling factor divided by the distance, adding that little bit to it because I don't want ever the distance to be or 0 or divide by 0. So I'm going to say, let's take that distance that we've computed and the scaling factor here. Okay, so this should now give us a whole bunch of different scaling factors for, or radius sizes for the different circles that we've put on the grid. The final step, though, is just to really reconnect all that. So we have all these different radiuses. Rather than using the default radius, which is shown right here, if I want to connect this in, okay, that'll give us the effect we're looking for. So let's kind of take a look at really what that looks like in action. So you'll see the number slider is currently pretty close to the origin, around 1 and almost 2. If I move it in the y direction, you can sort of see the effect of it moving up high. If I pull it back, you can see the effect of it being very low. Let me move it over in the x direction. You can sort of see it moving through over there. Now, this effect may just be too strong for what you're looking at. And if it is, what are we doing here? We're just dividing the scaling factor by the distance. I guess that's pretty good. Let's go ahead and just try sort of a different scaling factor and see if we like that effect any better. No, that I almost don't like. Let's go back the other way. Maybe that's a little bit kinder to see. So that you can sort of see things responding to that or not as we move those around. Okay, and that's the fundamental of the attractor logic. So again, we just need to create those target points. We need to create an attractor point, figure out what the distance is between them, and use that as something that we use to adjust the behavior of an element. In this case, we're doing it with some just dynamo geometry, which makes it happen very fast. For the next example, we're actually going to show you how you can do that same thing using Revit elements.